Hello friends, this is the third lecture of Fundamentals of Lasers, and in this part third I will discuss about the two types of lasers, which are basically the continuous wave lasers and pulsed lasers. So lasers are either pulse lasers or these are continuous wave lasers. So we have to understand the difference between the two types of lasers. So a pulse laser actually gives out laser light in short duration pulses, and these short duration pulses are shown here, and it between these pulses there is a gap, so there are no emission of laser light in between the different pulses. So short duration pulses with high peak power are produced by such type of pulsed lasers, and in this case, although the peak power is high, but if we take the average over a time, then we get a small average power. So these pulse lasers actually emit optical energy in terms of discrete pulses, and these pulses are separated by a time interval, and during which we do not get any laser light from these pulsed lasers. Some of the examples of pulse lasers are given here. Q switched ND Yag laser, which is a nanosecond pulse laser, and this Q switched ND Yag laser is used for drilling and surgery purposes. Another example of pulse laser is a mode locked titanium sapphire laser, which is a femtosecond pulsed laser. That means the pulse duration is of the order of femtosecond, which is 10 raised to the power minus 15 second. So this mode locked titanium sapphire laser produces very short pulses of laser light. Then another example is excimer lasers. These excimer lasers are actually UV pulsed lasers. It produces ultraviolet pulses, and which these pulses are used for the purpose of eye surgery. Then pulse lasers are also fiber lasers and pulsed CO2 lasers. So but the important thing about these pulse lasers are actually these give out the output in short duration pulses, and there is a gap in between the two consecutive pulses. So between pulses we do not get the output as laser light. Whereas in case of continuous wave lasers, these are the lasers actually that emit optical radiation continuously. So in this case we get steady uninterrupted beam of light rather than short pulses. So we are continuously getting output power from a continuous wave laser over a operating interval of time, and in this case you can see that the peak power is small compared to the pulsed peak power of pulsed laser. So the peak power is although small, but the average power of continuous wave lasers is quite large compared to the pulsed lasers. So here the laser is continuously providing output so there is no gap between the output intervals. We are continuously getting the output, and examples of these continuous wave lasers are helium neon gas laser, continuous wave CO2 laser, argon ion laser, solid state lasers such as ND Yag laser, and semiconductor laser is also an example of a continuous wave laser. So in this case peak power is small, but the average power over a time is large compared to the pulsed laser. Now here these two type of lasers can be compared on the basis of certain parameters. So these parameters are actually considered over here are the emission pattern of laser, the peak power produced by the laser, the energy delivery, and the typical applications of lasers. So for continuous wave lasers we can see that the emission pattern is nearly continuous. So we are continuously getting optical output from a continuous wave laser, whereas in case of pulse laser we do not get continuous output power from the laser, rather we get output in terms of discrete pulses. Now the pulse durations can vary from laser to laser. Some of the lasers produce pulses which are of the order of nanoseconds. So nanosecond means 10 raised to the power minus 9 second pulses are produced by such lasers. Some lasers produce picoseconds pulses. Picosecond means 10 raised to the power minus 12 second pulses are produced by these lasers. Some more advanced lasers produce femtosecond pulses, or even more advanced pulse lasers can produce pulses of the duration 10 raised to the power minus 18 second, or these are known as attoseconds lasers. So then on the basis of peak power we can see that a continuous wave laser actually have lower peak power for a given average power system. So if the average power is given, then the peak power for this continuous wave laser will be small compared to a pulsed laser. Now this peak power can lie in between milliwatts to hundreds of kilowatt for a continuous wave laser. However, if we talk about pulse laser, then these pulse lasers can produce or can achieve very high peak powers during each pulse, and this peak power can range from kilowatts to petawatts. Petawatt means 10 raised to the power 15 watts. So quite high peak power can be produced by a pulsed laser during its pulses. Then the third parameter on the basis of which we can compare continuous laser with a pulse laser is the energy delivery. So energy is delivered regularly over time by a continuous wave laser, whereas this energy is concentrated into short pulses or short intervals of time in case of pulse laser, and in between these short pulses we do not get energy delivery. There is no energy delivered by the pulsed laser in between different pulses. And then on the basis of typical applications we can see that continuous wave lasers find applications in various fields, like in continuous illumination. They are also used in spectroscopy, and they are also applied for alignment, communications, and steady material processing. Now these pulse lasers can be used in LIDAR. LIDAR is actually the light detection and ranging, which is a high-tech method to measure distances and build precise 3D maps of objects. So these pulse lasers can be used for LIDAR, that is light detection and ranging. These pulse lasers can also be used for micromachining. Again, the micromachining is an advanced manufacturing process which is utilized for making extremely small parts and features of the order of 1 to 500 micrometers. These pulse lasers are also used in spectroscopy and some other fields. So to sum up it, A continuous wave laser actually gives out a sustained or regular output. However, the peak power is small, but the average power over a time is large for a continuous wave laser. Whereas from a pulsed laser, we get short duration pulses, but during the pulses we get high peak power or high intensity energy delivery during the pulses. So these are the basic differences between a pulsed laser and a continuous laser. So different lasers are either pulsed laser type or of continuous wave laser type. So these are the two basic type of lasers on the basis of their output delivery, either continuous delivery of output or delivery of output in terms of pulses. So I think this is all about for the comparison of pulse lasers to the continuous wave lasers. I should stop here. Thank you.